Okay, ilikuwa swali but okay. Oh, so I hope you can hear me. Some people requested me to do a recap of what was done yesterday. So, Bede, can you hear me? Anyone?
Yeah.
Awesome. So, yesterday we did surface and interfacial phenomena. So, from what is said here, it's that when there is molecules in a liquid, those that are in the bulk, they experience interaction from all sides, but those that are in the surface, they are the attraction is mostly sideways and into the bulk of the liquid. But those that are at the surface mostly, it's into the bulk of the liquid, and that's how we get our surface tension. So those that are in the liquid, all directions, but at the surface, the attractive force is towards the bulk of the liquid, and this results in giving rise to the surface tension and surface. So surface free energy is the work that is done to increase surface tension. But when you equate those bulky equations, you just see surface tension is equal to surface free energy. So there's not much of a difference. They're similar fact. So if surface tension increases, surface free energy increases similarly. So yeah, so okay, this was basically talking about the Laplace equation, where if you have a bubble, you see in a bubble, it experiences pressure differences. The bubble itself is capped, so it experiences internal pressure and external atmospheric pressure. So that's why in the absence of any external forces, the bubble will be spherical in shape and it will remain the same size because the surface tension forces are balanced by an internal excess pressure. So they balance out, and that's why the bubble remains as it is. And that's how we came up with the Laplace equation, which says for surface, so the surface tension is always positive, and for the pressure difference to be positive, meaning the excess pressure inside the bubble, for it to be positive in such a way that the bubble doesn't pop, the radius has to be positive. Yeah, implying that pressure inside the bubble is always in excess, such a way that the bubble doesn't pop in a way. Yes, then influence of temperature, basically when you increase temperature, you'll decrease the surface tension. Yeah, that's just the basic information. Then we covered spreading coefficients, where we said for a material to spread, the adhesive forces, that is the forces between the unlike molecules, has to be greater than the cohesion forces. So an example is given for when you add oleic acid into water, it will spread as a film. This is because the force of adhesion, which is the force between oleic acid and the water molecules, is higher than the cohesive forces within oleic acid molecules. So when the adhesive forces, that is between oleic acid and water, is greater than the forces between the oleic acid molecules itself, it will definitely spread. Yes, now that is what basically we said here, and spreading will occur only if the work of adhesion is greater than the work of cohesion. I think that is also very, very important. Then we talked about capillary rise and tensiometers. And this part, so capillary rise method, you see this cos theta has to be less than 90 degrees. And I need you guys to just don't forget this cos theta, because I'll make reference to it in the next presentation about wetting and surfactant. So when cos theta is less than 90 degrees, the liquid will definitely rise in the capillary tube. And you know, with the capillary tube bores and all, the rising is very, very different. But when it's less than 90 degrees, just know the liquid will rise in the capillary. And how do we get this degrees, this cos theta to be less than 90 degrees? So, you know, we say spreading and all that happens when the adhesion force is greater than the cohesion force and all that. So for this degrees to be less than 90 degrees, the adhesion forces have to be greater than the cohesion forces, such that it's easier for the liquid to wet the glass as it rises up than when the forces inside the water molecules are higher, so it won't rise up. And that's how the surface tension is measured. I think I'll see if I can get a video for that capillary rise method. But basically, just know, you see these capillaries, I'm assuming we can be able to calculate now the surface tension once you key in those values. Yes, for the capillary rise method, you have to key in those values to these equations, which I think it's just important for us to understand this concept of the degrees being less than 90 degrees, where the adhesion force is greater than the cohesion force. That's why the liquid will rise. And when it's that way, you're now able to derive your surface tension values. But this paragraph here doesn't really, explain in depth how to come about that. You just have to calculate. Now for the Wilhelmy plate methods, I think this is what Saru mentioned she couldn't understand well. So I think a visual will be better. Visual will be better. So in this video, there's no sound. There's no sound, so it's just, so you just observe what is happening. So I don't know if we've understood it, but basically it's
the concept of surface tension is essential.
but you see, as you've seen from the video, like there's that plate. So they were hitting it, you know, for sterilization purposes, and also here it says this is okay. This method requires the contact angle that the liquid makes with the plate to be 0. This is usually achieved by scrupulous cleaning and roughening the surface of the plate. So this is why you saw them hitting the plate. So once this is done, to ensure that the contact angle with the plate is 0, the plate was immersed slowly into the liquid, and it's 2 immiscible liquids. I don't know if you saw that. So they read, as you saw, that one was automated, but according to this note, the reading on the balance prior to detachment. So while the plate is inside the liquid, they make a reading. And now when the plate is detached, they also make a reading. So basically, it's just understanding that this Wilhelmy plate method is used to determine the interfacial tension, because it's in, the plate is placed in between 2 immiscible liquids. Once you see 2 immiscible liquids, just know we are calculating the interfacial tension. So with that detachment, you get the interfacial tension. Then for the ring method, very, very similar to the Wilhelmy plate method, where we just measure the detachment of the ring in between the immiscible liquids, and that's where you get the interfacial tension. It's also automated from what I've seen in the videos, but you can calculate it if you have maybe the radius of the inner radius of the ring, outer radius of the ring, and the force of the detachment. You can calculate the surface tension or the interfacial tension. So I don't know if you understood me with this capillary rise method. You see this height is what we are measuring. So if the value is not less than 30, it won't rise. I mean, less than 90 degrees, it won't rise. So once we get this height is when now we come and calculate our surface tension from this formula. Yes, from this formula, where you'll have now the height of the liquid, the density difference between the liquid and its vapor, and the acceleration due to gravity, then you'll get your surface tension. But I think I don't know if they make us calculate that, but I just think it's important to just know the basics of them, of the methods, because these are technical equations. And then now for the drop weight and drop volume methods. So they might measure, like in the labs, they can measure like up to 10 to 20 drops there, about the initial weight of that beaker prior to the drops, then the final up to 3 readings. Then they take the average volume and mass, you see. So this is when you come and substitute here. You have the mass of the drops, you'll have the volume of the drops, because you'll measure from the measuring cylinder, the mass, you'll have it. Then the radius of the tip of the syringe, acceleration due to gravity, and the correction factor. Once you key in this, you can be able to calculate the surface tension. I hope we know that this symbol is the symbol for surface tension. So that's basically it for the surface and interfacial phenomena. Then we talked about wetting, sorry. Wetting basically uses surface active agents which decrease surface tension. Even soap is a wetting agent. It decreases the surface tension of water. So and how do they do that? How do they reduce the surface tension of water to allow wetting? They reduce the contact angle. Yeah, so the contact angle has to be less than 90 degrees for wetting to occur. You see, this is what this paragraph here is saying. During penetration into capillaries, let's say without extra pressure being applied, the adhesion tension must be positive, hence cos theta is positive. In short, the contact angle has to be less than 90 degrees for penetration to occur. So that means the surface tension has been reduced for wetting to occur. Yeah. And just as it's saying here, surface active agents are commonly employed in formulations. They have to be employed in tablets and all that, so that the contact angle is reduced to aid wetting of a solid by reducing the surface tension or interfacial. This looks like interfacial tension between the solid liquid interface, liquid gas all that. You need the surface active agents so that they can reduce the contact angle and aid wetting with substances. Then adsorption at liquid interfaces. So what do we know adsorption is? It's the deposition of some molecules to the surface of a liquid, because we're talking about adsorption at a liquid interface. So there is positive adsorption and negative adsorption. Positive adsorption is when the molecules that are introduced maybe into the liquid, they deposit on the surface of the liquid. So what do? They decrease the surface tension and surface free energy. And here we said the concentration is very necessary of those surfactants. So here we're talking about surfactants. The concentration is necessary to produce an equal lowering of surface tension. So where we said for each additional CH2 group, the surface tension decreases by a factor of 3. So you see, when you have like Now I want us to employ our imagination, like when you have a bowl of water and you've introduced surfactants. So if they deposit on the surface of the liquid, they'll definitely lower the surface tension and surface free energy. And that is what we call positive adsorption. And for it to reach equilibrium, the deposition of the surfactants to the surface or whatever molecules you have, it depends on factors such as the molecular size, shape, and the presence of impurities. And impurities tend to lower surface tension. Now, for negative adsorption is when they don't deposit on the surface. So they mix with the liquid. So for here, surface tension will definitely increase. And this is seen with solutions of sugars and electrolytes. Like when you add sugar to your tea or coffee or whatever, it doesn't deposit to the surface. It mixes with your liquid. So surface excess concentration is, in short, here we are, just as the word suggests, it's an excess of the concentration at the surface by surfactants or whatever molecules that you have, which is not like normal for us to see in normal reference situations. So what can I say about this? So as the concentration of those surfactants in aqueous solution is increased, the surface layer will eventually become saturated. This is what we're talking about when we're referring to surface excess concentration. It will exceed even the equilibrium. Now, when it's saturated, the surface, any further increase in concentration will not change the surface tension. And now the surfactants will form micelles, which are small aggregates of molecules. Yes, they'll form micelles. And so here we say now the critical micelles concentration has been reached. And there's, even if you add 1 million surfactants, the surface tension will definitely not change. And now for the monolayers, it's basically, we said monolayers also reduce surface tension of water by an equal amount to the surface pressure. You see, monolayers are employed in dosage forms, and they've been used to study polymers, which are used for film coating and packaging. Yeah, it's important to have this in your film coating stroke packaging of tablets, because we know it reduces the surface tension of water, so it will allow water to penetrate the tablet, and the subsequent processes that we want to occur to that tablet will definitely happen. And now we also talked about surfactants. Are we together? Okay, I assume we are together.
Yes.
So, okay, so, and I hope we are understanding also. We're also understanding. So surfactants, as I've been saying, they just lower the surface or interfacial tension. Surface tension is for a single liquid, but interfacial is for immiscible liquids. So surfactants tend to lower, and this hydrophile-lipophile balance is a number that describes the HLB nature of the surface active molecule. So how is it calculated? You take a sum of the hydrophilic groups, hydrophilic, water-loving, minus the sum of the lipophilic groups, then plus 7. So for surfactants which have the HLB value of less than 9, they're lipophilic, and the smaller the HLB, the more the lipophilic character. So, and for this, the ones that have HLB values less than 9, they form water to oil emulsions. Sorry. So for an HLB value of less than 6 signifies an oil-soluble surfactant, and those in the range of 1 to 3 are anti-foaming. So they won't form. But for those who have an HLB value of above 9, they form oil to water emulsions. So the higher the HLB value, the more it will be the hydrophilic character. So they form oil to water emulsion. And we classified surfactants where we said anionic surfactants. They have their surface active portion. The active portion is of negative charge, and they're the ones which cause skin irritation. They have unpleasant taste, and they are definitely not compatible with cationic surface active agent, but they are compatible with non-ionic and zwitterionic. Examples, it's like, I don't know if you people have ever tasted shampoo. I have, and the taste is not very pleasant. So examples you see, there are those with sulfates, like the sodium lauryl sulfate used in toothpaste, shampoos, other cosmetic products, anything with sulfate and sodium and potassium salts. Okay, majorly sodium lauryl sulfate. You might be asked, is this which class of surfactants does sodium lauryl sulfate fall under? It's anionic. For cationic surface active agents, for them, the surface active portion will be positively charged, and they are majorly bactericidals. And they're the ones, since they are negative, they can absorb onto negatively charged surfaces, so they can be used as fabric conditioner, softeners, hair conditioners. Yes, but they are incompatible with anionic. An example is dodecyl ammonium chloride. We have, in short, anything with ammonium salt. They are cationics. Then for non-ionics, they have no charge. So they are not affected with presence of salt or changes in pH. And they include twin. I don't know if you people have been seeing this twin all the time. I've been seeing it. This twin is an anionic. It's an anionic surfactant. Yep. Now zwitterionic, they are compatible with all the other types. And for zwitterionic, they used to boost the forming properties of other surfactants. Oh, and I forgot to mention that for quaternary ammonium compounds, they're among the most utilized cationic surfactants. So yeah, that is very important. So zwitterionic, they just boost the forming properties of other surfactants since they're compatible with all of them. Then, yes, this is what I was talking about, the critical micelle concentration. So surface tension will decrease, of course, with increasing concentration of surface active agent. And however, at a certain concentration, it will stop decreasing and it will reach a plateau. So this concentration is called the CMC, and yeah, it's basically that, it's the CMC. So we see this without just interfering with the surface tension, it also interferes with interfacial tension. See, as we increase, it will decrease the interfacial tension. For osmotic pressure, as you increase the concentration of the surfactant, definitely the osmotic pressure will increase, but it will reach a point it will plateau. For drug solubility, it will increase because we are decreasing the surface tension, so it's easy for penetrability and all. So it will increase. Then it after the CMC is reached, it will still increase. Since you're saying the micelles, they'll form in the bulk to protect the hydrophobic groups from the aqueous environment. So I'm thinking, correct me if I'm wrong, but if you increase surfactants, you see, and you're protecting the hydrophobic portions of the bulk from the aqueous environment, the drug solubility will definitely increase. And for detergency, okay, you see it plateaus, increases, then it plateaus. I just believe it's something to do with the micelles protecting the hydrophobic groups in the aqueous environment. I had written this explanation somewhere. When I get it, I'll share in the group. But I had written how they all relate to the CMC. Then now adsorption at solid interfaces, we described this using the isotherms. And we said adsorption occurs by van der Waals, the weak van der Waals forces. And we have physical adsorption, which is rapid and reversible since it's weak forces. But for chemisorption, it's the valence forces and they're stronger. So they require an activation energy and therefore they're not readily reversible. So the isotherms, we had type 1, where it's for the chemisorption type. Since we're saying specific, it's slow and not readily reversible. So these isotherms exhibit a rapid rise in adsorption up to a limiting value, then it plateaus. And it's not reversible, so it remains like that, in that plateau. Then type 2, and it's for monolayers. Type 2 is multi-layers, and it's physical adsorption. It's reversible, so I'm thinking it will get here, reversed, continues like that. Then for type 3 and 5, adsorption is in the first layer, is weak and rare. And for type 4, it's for due to condensation of vapor in fine capillaries within porous solid. I don't think these isotherms are very important, but what can they do with an MCQ? Maybe they ask you, what type is this? Is it type 1? Type 1 is for what? I think that. Yeah. And then we talked about the Langmuir adsorption isotherm. This is applicable to type 1 isotherms. I think that's enough. For Freundlich adsorption isotherm does not predict a limiting value, as does the Langmuir equation, but for the BET, describes the type 2 isotherms. They're just equations, so not really important. Then for adsorption from solution, so these factors, of course, the concentration, solid concentration, temperature, pH, and surface area of adsorbent will interfere with the extent of adsorption. So increase in concentration of solute will cause an increase in the amount of absorption. Increase in temperature, decrease in absorption. pH, it depends with the species that you have. There are species that will be more strongly adsorbed depending on the solution that you have. Surface area of adsorbent, increased surface area, increased adsorption. Yeah. So this was for applications. So you were saying adsorption causes problems in formulations where you find your preservatives, they've adsorbed to containers, so they reduce the effective concentration. And additives such as parabens, they might also be adsorbed to solid materials, leading to loss in antimicrobial activity. So that was that for surfactants. Then Then the last one was for the electric double layer. I hope you guys are understanding me. And it's not too much. Maybe should we go to the next dissolution and all? Then, because time is moving, then when Chai will be doing a recap, we'll start from maybe electrical properties, then and a recap of what he will have done tomorrow, if that's okay with the ones present. Good. So yes. So Chai, you can start. But I hope you've understood
Yeah.
that was a factor, capillary, all that. So
Good evening, guys.
evening.
Hope you can hear me clearly.
Yeah, yes.
All right. So I'll be taking us through solubility and dissolution. So solubility and dissolution, they are pretty straightforward. I don't think we'll spend more than an hour in this topic because most of the application of this concepts something that we do daily basis as we see. So let's start with definition of solubility. I've seen it being frequently tested in the board exam. So solubility can be defined as the concentration of a solid in a saturated solution, usually at equilibrium, and it has to be at a given temperature and pressure. Yeah, so that's it. So there are many definitions for solubility, but basically that's it. Solid in a solvent at with the endpoint usually has to represent dissolution capacity of the solid. An example of this could be like salt in water, or salt or sugar in water. Okay. So with the solubility, there has to be like a universal standard or a universal convention of 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 what to determine solubility, and this is usually they use what is known as a solubility expression. That's something that the US Pharmacopoeia USP and the National Formulary came up with. So the solubility expression basically denotes that a substance has to be, for it to be described as soluble, it requires between 10 and 30 parts per mil of solvent to dissolve 1 part, that's in gram, of the solid. Yeah, so basically that's it. Has to be they usually use this parameter. This is a chart showing an example of what we're talking about. That's the solubility expression. So you can see for a substance that's less than 1, described as very soluble. A substance that between 1 and 10 is really soluble, 10 to 30, and that's per 1 part of solid, which is in grams. So 10 to 30 is extremely soluble. You guys can go through this on your own time. But yeah, that's what the solubility expression is used for. So the salts of weak acid and weak bases usually they are completely ionized in water and are very soluble. So let's look at the factors that may usually affect solubility. We've already described it as the concentration of the solution at saturation. That is when it's at equilibrium, the given temperature, and also at the given pressure. Let's start with the most common, which is temperature. Temperature is one of the principal factors that affects solubility. And temperature affects solubility of substances differently. For example, there are some substances that once you raise the temperature, you increase the solubility. And others, if you raise the temperature, you reduce the solubility, as we'll see. And so, yeah. So here they have there's something they call the change. The change. Yeah, here. I think you guys can see my cursor. So the overall exchange of energy can either be positive or negative. And so this overall energy exchange is called the heat of solution. Yeah. Because usually, for example, if you're breaking, let's take an example of sodium chloride in water, those crystals, you require some energy to break up the crystal lattice structure for you to, at the molecular level, so you can separate it into ions. And then afterwards, then the solvent also, there'll be some energy expanded by the solvent to break those hydrogen bonds and for it to come into contact with the solid. And now this is referred to as the heat of solution. So when the heat of solution is negative, an increase in temperature of a solvent usually will reduce the solubility of the solid. An example is in a compound like calcium sulfate in water. So as you guys can see, like there's no general rule for that. And then if the heat of solution is positive, increase in temperature of the solvent also increases the solubility of the solid. An example of this would be sodium chloride in water. Although, okay, let's not use that because they're saying here we have highlighted because there's only a slight temperature effect on the solubility of sodium chloride. And so let's take another example of something like sugar in water. This one will be, it's going to be evident. For the sodium chloride, it's a bit nuanced. You have to be too keen for you to note that difference. But yeah, it's the same concept that raising the temperature will increase the solubility. I hope you guys are following. So the other factor is, yeah?
I'm saying we are following.
Okay, Oscar. The other factor is polarity and hydrogen bonding. So here the chemical structure usually it influences the solubility. This could be something like a structure like the dipole moment, the dielectric properties, and the hydrogen bonding, as you'll see in the breakdown. So with the it's with the dipole moment, molecules that have a high dipole moment, such as water, they're more soluble in polar solvents because of the charge distribution and the orientation. And the other factor is the dielectric property. Dielectric property means the ability to store charge. Yeah. So here we can see they're saying that water has a fairly high electric constant, the electric constant of 80 at 20 degrees compared to alcohol, which has a dielectric property of 25 at 20 degrees. And yeah, so even both, yeah, they're both considered polar solvents. The other factor is hydrogen bonding. Sure you guys know much of this hydrogen bonding. So any molecule which has a functional group of hydrogen, such as hydroxyl, this amide, the sulfur and hydrogen bond, and therefore be attracted to water. And this will therefore increase the the molecule solubility. The other factor is the particle size. So when you reduce the size of a particle, you increase the surface area to which it's exposed to the solvent. An example of this would be something like, sure some of you guys might know of a supplement like creatine, the micronized creatine. So the fact that you've reduced the particle size, it increases the solubility. Because now the process that's required to break down the crystal lattice of the solid, it's not so much. It's it's less after you've reduced particle size to a micronized molecule. And so this crystal lattice energy holds the solids together and increases the energy required to separate the ions or molecules for solution formation. As you can see, since there won't be much, you're reducing the overall energy, the heat of solution required, thereby you'll increase the solubility. So these solubility rules are just what we've covered in the factors that affect solubility. For example, the first one was the one about polarity, where like dissolves like. Yeah. The other was the solubility with compounds that have a hydrogen bond, this functional group. This hydrogen bonding will increase the solubility. Then the other one, they're talking about compounds that have large the carbon chain. The longer the number of carbon atoms, the more insoluble the compound is. Yeah, and also molecules with a high melting point also means lower water solubility. Another one is that cis isomer is more soluble than the trans isomer, because the cis isomer usually have a lower melting point. Something else that would behoove you to know is increasing the saturation leads to increases solubility in polar solvents. Then also anhydrous solids are more soluble than the crystalline ones for the similar reasons, because of the overall energy required to break the lattice in the crystal. Okay. Then we have something that's referred to as a solubility product, which is This is what's used to determine solubility of poorly soluble strong electrolytes in water. This is how we determine it using the KSP. So they're saying this solubility product is a constant which is equal to the product of the equilibrium concentration of dissolved ions of a salt, with each ion raised to its stoichiometric coefficient. Yeah. So this formula best applies when there is no complex formation of the ions and is suitable for inorganic salts and hydroxides. So here we can see an example here. For example, we can calculate the solubility of a calcium carbonate in water using this the solubility product constant, whereby we're given, so here you just have to write the ionic equation, calcium carbonate, and you have to balance it out here. So the charge, I think the charge is here. Yeah, so it's balanced. So here the KSP, in the KSP of this the reactant. Oh yeah. Is there anyone who can understand this formula? Like where they got it from? Like the C, where they're denoting the C and the S. Or they've just given this example. I don't know what this is. Maybe we'll get back to that.
What is that calculation about? It's for searching for?
For the solubility product of the products that are the compounds that are usually polysoluble.
Formula backspace. About scroll to the top of that.
Hmm?
Oh, there's nothing up. Oh, okay.
Yeah, that's one.
Solubility constant, product constant. Okay. I don't think I also know.
Do you get it,
No.
Diana?
I think so. Just let me do the. Yeah, I'm thinking it's the let me do 9 points. I think they're just saying, okay, maybe we go through it together. We see if we've understood. So one can calculate the solubility S of calcium carbonate in water by using the solubility product constant KSP, which is 9, that one, at 25 degrees Celsius, where the dissociation equation at saturation is that. So, and the stoichiometry gives calcium plus 2 is equals to carbonate 3 minus 2. So in short, the solubility product after you've dissolved calcium carbonate is calcium and the carbonate, which it's saying the solubility like constant is equals to the concentration of calcium, which is also similar to the concentration of carbonate. So they're saying we set CS2 plus. Now this CS2 plus, could it be a typo? Because here down, here for the CS2 plus is, so the bracket is concentration. Yes, it's that, but we don't have that in our equation. Like when you see for this one for magnesium hydroxide here down, they're saying set S, I'm thinking set solubility is equals to magnesium, then 2S is equals to OH, indicating that the concentration of hydroxide is twice the concentration of magnesium. So it's just basically calcium. Like you see for this for magnesium and hydroxide. Here down. The S is the magnesium and the 2S is OH. So it's those things for, what's it called? Those constants, but I think we can just continue, then we will we'll discuss it when.
Although I don't know how complicated they set it. But we might,
Yeah, it was definitely a typo. Thinking it's a typo.
these are the table they're talking about where they have the different solubility products of compounds. So let's look at solubility of weak acids and weak bases in water as influenced by pH. As we know, most drugs usually are either weak acids or weak bases. And usually the more polar ionized form the drug is, the more water soluble. That's why it's important for us to understand the relation of the pKa and the pH of either the weak acid or the weak drug. So weak acids by definition are those that dissociate partially in water to give hydrogen ions and weak acid anions in equilibrium as represented by this. So when a weak acid is added to water, it dissolves and up to saturation, and the concentration of the solution is a solubility of the weak acid. So what this means, for example, if the weak acid is in an acidic condition, there will be more concentration of the hydronium ions. Thereby, the solubility of the weak acid will increase in an acidic condition because of this ionization by those ions, which will help it to dissolve more rapidly. And similarly, a weak acid at a higher pH means it's more basic. So at high pH, the concentration of hydrogen ions is going to be high, and this will increase the weak acid. Since I'm sorry, at high pH, the concentration of the hydroxyl ions is high, right? So the weak acid will stay unionized, since there will be a neutralization between the excess of the hydroxyl ions and the hydrogen ions. So thereby solubility of weak acids at a high pH reduces as a solution becomes more basic. And the opposite happens for weak bases. So we can define the weak bases. Weak bases are those that react with water to become, they are protonated and become the associated weak base to give hydroxide ion at equilibrium. Yeah. For example, a weak base in like in an acidic condition or low pH, the weak bases will they tend to be protonated. That is again hydrogen ions, and this protonation reduces the solubility of weak bases in an acidic condition. And at high pH, there is a high concentration of hydroxyl ions, and these weak bases they're more likely to accept hydrogen ions and become more ionized, and thereby increase the solubility under this under whatever basic conditions, sorry, under acidic conditions. Sorry. I don't know if we need to go through this calculation. I feel like someone had covered it. I think it was Corazon. These calculations are pH pK. Yeah. So let's look at factors that affect I was talking about miscibility. It's almost similar for for solids. Yeah, I think this yeah, we had already looked at this. How high molecular weight compounds are not are most commonly they're usually insoluble in water. And thereby we might need to use other means or mechanisms to improve the solubility, such as co-solvents. If I can find another, so second. Yeah. So yeah, so to the, can you guys see my screen?
Yes.
Yeah.
Yes.
So once we have solubility problems, there are some factors that are used to usually to enhance or to optimize, that you can use to optimize the solubility of this or either your therapeutic agent. One of these is let's look at them, is selection of a drug salt. An example of this would be like the sodium salts of penicillin, or something like phenobarbital, which is mostly insoluble. But once you combine phenobarbital and sodium, and you find that it's more soluble in organic solvents. So differences in solubility may be accredited, at least in part, to the crystal properties of the salt, which in turn affect the energy required to dissociate the solid-solid bonds as the crystal lattice. Another method is optimization of the pH of the formulation. This is where you regulate the pH or the pK. Importantly, the acceptable range of solutions for oral administration range from 5 to 8 pH units. Therefore, the formulation strategy involves selection of the pH value for the formulation, which optimizes the ionization and hence the solubility of the agent that you're looking to improve in this case. Another method is use of co-solvents. So co-solvents are liquid components which you can incorporate into formulation, and they enhance the solubility of compounds that are initially insoluble to a more acceptable solubility level that you're looking for. So commonly used co-solvents include glycerol, propylene glycol, ethanol, most commonly used as well, and polyethylene glycol. Yeah, so that's it. Those are some of the parameters that you can use to improve solubility. Now let's go to dissolution. Or do you guys need a break?
We are good.
You're good.
Acha kuchoka mapema chai, twende kwa kazi please.
Ati unaenda wapi?
Endelee. Sisi we are energetic.
Hataki cigarette break.
Hatutaki cigarette break hapa tafadhali. Sawa.
Yes.
Ama unataka kuendea maji? Tukupe 3 minutes. But us we are ready. Tuko sawa.
Yeah. So can you guys see my screen?
Yes.
Yeah, so as we said earlier, that solubility and dissolution, they share some similarities, and we've defined solubility. Now let's look at dissolution and how it pertains solubility. So dissolution, it can be important, guys, to know the definition. I've also seen it being tested. It's a process by which a solid solid enters into the solution in the presence of a solvent. Yeah, this means dissolving a solid in the presence of a solvent, as you stated. And this is specifically important for in vitro studies, because as we see, as you guys might have seen during your placement in the industry, how it's a common regulatory parameter for that you have to comply with, to ensure there's batch to batch uniformity of your product. And so for dissolution, we have something they are calling the diffusion layer model, which is I think it was developed by these guys, Noyes and Whitney, which is just tries to, I think it's almost similar to the solubility product as a means to determine dissolution. Yeah, this is a model. I hope you guys can see it. Here we have the drug particle, the diffusion layer, and the bulk solution. So the dissolution of a drug from the powder particle into the large excess is to the bulk medium is described by this model, this diffusion layer model. And this model assumes that a stagnant liquid film this model assumes that stagnant film, liquid film, usually forms on the surface of a particle with a thickness denoted H in centimeters. And this liquid film constitutes a stationary diffusion layer in which the concentration of the drug is described by this CS. And beyond this height is a bulk medium, where the concentration of the drug CB. Yeah, so from this model, they come up with the Noyes-Whitney equation. Yeah, here, which is this is what it's used to determine the dissolution. No, these guys are thinking. And so in this equation, M is the amount of the drug dissolved in units. Usually it could be in the units is milligrams or millimoles. In the time units, usually in seconds. And D is the diffusion coefficient of the drug. In the units is centimeters squared per second. And then the S is the surface area of the particles in centimeters squared, and H is the thickness of the liquid film. Okay. Yeah. Yeah, and the CS, yeah, at the far end of the diffusion layer, is the concentration of the drug at the surface of the particle and the bulk medium, respectively, particle and the bulk medium. So the CS is considered to be the saturated solubility of the drug at the temperature at which the experiment is set. So here we can look at an example, yeah, and see how we can apply this Noyes-Whitney equation in determining dissolution. So here we're given they're saying calculate the dissolution of a relatively hydrophobic drug. They've given us the surface area, the saturated solubility, 0.35, temperature, and the diffusion coefficient as well, and the thickness of the diffusion layer in micrometer. So you have to change this into centimeters. So the concentration of the drug in the bulk you're given. So here you just key in this into the formula. Yeah. So let's look at it together. So here you convert the micrometers to centimeters. We've done that. And so you get the rate of diffusion by, dissolution by the product. That's the diffusion. You get the diffusion coefficient, which is this, given us. Also given us the S surface area, which is this one. Surface area of the drug particles, and divided by the height in centimeters. This is the height. Yeah. You get your evolution rate. Similarly, if they change the surface area, that's just key it in into the formula. I hope you guys are following.
We are trying to follow, but we are following.
Voilà, basi. Hapa you just
Maths inanishindanga mimi chai.
oh. Yeah. And also nilisahau kuweka nini about this they call these concentrations. Concentration at the surface of the particle, the CS, minus the concentration of the particle at bulk, PCB. And you subtract it. I don't know if an instant they would give us this, if they'd give us the formula. Yeah, that's it for the Noise-Whitney equation relationship. The Noise-Whitney equation that's used in determining dissolution. The other topic I'd like us to look at is dissolution testing. I will look at various types of the parameters used, dissolution apparatus. Yeah, and what specific type of drugs that they test. So here, guys, I've got a video, short video that I think would help us see about this apparatus. Don't mind my.
Chai hatusikii. I think unafaa unmute then you share the sound. No, like unmute Zoom.
Oh, let me start over.
And then hapo kwa ushare sound. Hapo kwa view options.
Is it?
Just under Zoom.
Copy Dana.
Okay.
Wait, hamko mnaisikia all that time?
Yeah.
Uses
Mnasikia?
apparatus 1 is rotating basket. It is useful for conventional tablets, chewable tablets, and controlled release formulation. This is apparatus 1. Apparatus 2 is rotating paddle, useful for tablets, orally disintegrating tablets, chewable tablets, capsules, controlled release products, and suspension. Apparatus 2. Apparatus 3 is known as reciprocating cylinder, useful for controlled release formulation and chewable tablets. Apparatus 4 is flow through cell for formulations containing poorly soluble drugs, powders, granules, microparticles, and implants. Apparatus 5 is known as pedal over disc. This is fifth apparatus, pedal over disc, useful for transdermal formulation. Apparatus 6 is also useful for transdermal formulation, used as cylinder. And apparatus 7 is reciprocating disc, useful for controlled release formulations, non-disintegrating oral formulation, and transdermal formulations. Now, useful for
So guys, I could leave this for a few minutes. Maybe process that information. So I take it you guys are done. I'd say we don't have to go through the video. It's a bit tedious. Yeah. So we've seen this apparatus and the various type of drugs that they're used to test. Now let's look at the factors that affect dissolution. So we've talked about the significance of dissolution. One is that it's important. It's an important QC test for pharmaceutical products, just to ensure there is compliance with the USP guidelines. And most of this dissolution, they come with a monograph, so I don't think we have to cram the process. What's going on in these different apparatus. Yeah, so let's look at the factors that affect drug dissolution. So for dissolution, so these factors could be grouped into like three major categories. One is the physicochemical properties of the drug. The other is formulation factors and physiologic factors. Let's get some next and summarize. Yeah, so with the physicochemical properties of the drug, these are the properties that might affect the API. One is the chemical form, such as if the drug is ionized or unionized. So as we've seen earlier in solubility, is that the ionized form, like salts, they are more water soluble, while the unionized ones are less soluble. Yeah. And then another factor is the particle size, which we already looked at when we were talking about the micronization of these elements. So reducing the particle size, you create a larger surface area, thereby you enhance the dissolution rate. For poorly soluble drugs, decreasing a particle size can significantly improve the dissolution rates and the bioavailability after oral administration. One example of this method is micronization. A number of drugs available in micronized form are such as nitrofurantoin, glycylfulvin, or ramphenical, and also something like creatine, the micronized form. Okay. The other factor is the crystalline state. Crystalline drugs dissolve more slowly in water than amorphous forms. This is because the crystalline drugs you require more heat of solution in order to break this crystal lattice. Whereas in amorphous, there's less energy required, and so that's why they have more solubility, the drug in a more amorphous state. An example here is lyophilized products, is dried products. So they're saying this enables quick dissolution upon reconstitution. Corticosteroid. So polymorphic transition sometimes may lead to slower dissolving of a drug by changing it from either from a faster dissolving crystalline structure to a slower form. Yeah. The other factor is formulation factors. So here, formulation factors, we look at different types of dosage forms. For example, you guys know about the immediate release, which are more rapid, and thereby, of course, they'll have higher dissolution. The other is the extended release, which are much slower, but they have an extended period of action. Other types would be tablets that are formulated to the solid dosage forms, like tablets, suspensions, caps. Yeah, you find they'll have different dissolution rates. This would be dependent upon the particle size that they've been formulated. Then the other factor is physiologic factors. These physiological factors, one would be the pH of the tract. For example, as we seen earlier in solubility, is that weak acidic drug, they would tend to dissolve poorly in an acidic pH, such as one in the stomach, or since there's less of the drug, will be ionized. And also people who are in the fasting state. We're talking about, yeah. Yeah, I was talking about how this the GIT emptying and the GIT transit time also affects solubility. Dissolution. So based on the time that it might take in the stomach, yeah, this would affect also the uptake of the drug or its the rate of dissolution. So if the emptying time is much shorter during the fasted state than it is during the fed state. Here they're saying that the transit times of solid dosage forms in these areas of the GIT tract have marked effect on dissolution, absorption, and bioavailability. So the more the transit time could also mean a longer, slower dissolution rate. And then we've talked about pH. I think that's it. The other, something else is physical chemical interaction. For example, there's drug food interaction. You'd find some drugs taking longer to be dissolved after you've eaten you've taken food. Yeah. And also there could also be other drug interaction, drug food and drug. So the drug interaction would be such as complexation of drugs, as we might have seen in those antacids. Once the complex, it may be say other with their salts. Yeah, it may take a longer dissolution, or even it might be impossible for them to dissolve. Yeah. Yes, I think that's it. That's it for solubility and dissolution. So do you have questions? Is there something you'd like me to go back to? It? We can do a record.
I think we're good. I just wanted to ask Chai, like, did you see any maybe any questions tukipitia kwa hizo papers relating to this
Yeah.
this subject area, ndio maybe tuone ka tunaweza zijibu.
You want us to go through the questions or the but I don't know. Let me see.
Doesn't even have to be all of them, but maybe just maybe. There was a plan for when we'll go through the questions for pharmaceutical.
Yeah, there's some questions.
Yeah, I was thinking maybe we could look at that. Tuone vile tunaweza.
Letting ako nini? Did letting present on I think instrumentation or something.
Waiting. Sijui kama ako kwa meeting.
Okay, we don't have a presenter. Maybe we can go to the question. Oh, so we can go through some perspectives.
Yes.
Can you guys see my screen?
Yep.
Hands up. Yeah. So let's start at number 63.
Na 61 Chayama 61 your solubility.
Yeah. This one I'd go with Penji.
Which of the following salt forms has the highest water solubility?
I don't know about this, but I know it's more soluble than fucking penicillin. I don't know about the rest.
It's because of sodium.
Yeah.
That's okay. So ina ionize inakuwa more soluble. Okay. Cl. Alright. Tutaenda na jibu yako mwalimu. Penicillin G sodium. The
Yeah.
next one
Ama
is
tuangalie ChatGPT pia.
GPT G.
Taki kuwadanganya.
Naka correct.
I mean, this is pharmaceutics.
Yeah, that's not pharmaceutics.
So bado hatukuijibu.
Ati?
I don't think tulianza hii 62. So the dissolution of a drug particle is controlled by all of the following except we have particle size. Yeah, we already looked at that. It does. Crystal habit. It does.
What is crystal habit?
Hiyo tulikuwa tunaangalia kama if nini it's the polymorphism, if it's either crystalline form it's amorphous. And we've seen the amorphous particles or compounds, they're more likely to dissolve quickly because of there's less energy required to break his or lattice, the crystal lattice. And so if a compound has its crystalline in nature, it would require more your heat of solution to break your crystal lattice, thereby less dissolution.
Less dissolution. So amorphous has a higher rate of dissolution compared to crystalline. Based on
For
what you've just
isomerism, I think it was it solubility?
Yeah, isomerism was under solubility about the C's
This
and trans.
yeah.
Mm,
On C's ndo
more soluble.
Yeah.
Due ya lower melting point.
I don't think isomerism does. Chemical
Dissolution
form does. You know, chemical form ilikuwa inaongelea pia hizo stories za nani, ionized, unionized, and also crystal.
So
Yeah, so
well, no,
I think I'll go
isomerism because it
with-
fell under solubility.
I didn't see isomerism in dissolution.
Okay. Ina make sense. Acha tunanga marking scheme ama tunaenda tu na what we think is right.
Hakuna mtu anaweza tuangalia ChatGPT.
Acha ni Google, acha nijaribu. Dissolution. Solution. Crystal habit equal. So that can't be the answer. Particle size equal. So A, B are there. Particle size, surface area, crystal habit distribution. So and or solid state. Okay. Hydrodynamics, and let me see if there's anything else between your chemical. The ones nimeconfirm.
Confirm particle size, crystal habit.
Yes, nimesikia mtu
I think
ana
isomerism. I think isomerism is the right answer because I remember organic chem tukiongelea isomerism. It was maybe when it's a different, maybe isomer iko na different mechanism of action to another different isomer.
Yeah,
So
I think we can be
ukiona
comfortable
the
with
rest,
that one.
then, yeah.
Sawa basi.
Brenda
Alright.
na Dr. Belinda.
Yeah.
The next, all the following statements are true regarding partition coefficient of a drug molecule. So, we covered this.
That's true getting partition coefficient. Partition coefficient inafaa kuwa Diana Tebut.
Actually, chai unafaa cover your partition coefficient pia. Think maybe
Okay, if it wasn't in the, I think that was the next whatever topic.
then yeah.
And we watched it.
But acha tu tuone iko aje. So tuipitie after number 64. Tuipitie after tumeisoma, right?
Hizi zingine sawa.
Okay.
Resignation.
Ni
I
hizo
think
tu.
65.
Taro ina
Which
affect.
one?
Crystal habit ina affect. Sorry.
Which one of the following principal salts is used in buffer mixture?
Karo ilikuwa inasema except. Ilikuwa, that question was saying except, so tulienda na isomerism, the last one. So cause tumesema hizo zingine tatu zina affect your crystal habit, chemical form na particle size. Hiyo ya mwisho ndo tumesema hai affect.
But it affects solubility.
Which of the following principal salts is used in buffer mixtures? Me hata siwezi kufanya Google. So hakuna sodium.
Hii ni paper 2 ama ni paper 1?
Chai.
Chai. Hii ni paper 2 ama ni paper 1?
Think that
Is it a
nimeangalia.
inakaa paper 1?
Kidogo.
Ama haina. It's not saying. Lakini ni maswali ni moto.
Maswali.
Mi hata mi hiyo exam mi sijui sasa akikutendaje.
Oh yeah, ni paper 2. Ni paper 2 nimeona.
Paper 2.
Unajua aje difference, Diana?
Like the kind of questions zenye ziko. Ebu you
Pia tu imeandikwa
accelerate.
mahali.
So I've started seeing questions of pharmaceutics. Come from number 76,
Zero order,
27,
accelerated stability,
28.
physical chemical, and hydrolysis.
Number 80, Ebu your 80 is not a component of INS equation, ni pH for sure.
Ni pH.
Hii paper I think tulikuwa tumeipitia. Mlikuwa
Hii Cunningham,
historia ya
it was
Cunningham tulipitia.
it was Z and E, ama?
It was Z and E, it was not R and S.
Okay. Okay, so next. Ebu your neutron. Oh, sawa. Down.
Any organic chem. Okay.
So wana mix.
Wana
Because
mix tu. Unaona pharmaceutics moja. Hakuna order hapa. We unaingia tu vile huko. Because this is a lot of organic chem.
Yeah.
Competitive antagonist. Acid.
ni kama swali za nini zimeisha. Oh yeah. The rate of the absorption of a drug can be increased by reducing the drug particle size.
Yes.
Yaani uko na pepa yenye iko na hizo nini?
Nimeona hapa for Z and E, sijui okay ni nani, but whoever okay is for specifically for the Cunningham system for nomenclature for this ilikuwa nini enantiomers. That's when we were using Z and E for the alkenes kuonyesha. I think E was the one when the groups with the highest priority were on the opposite side of the double bond, and then Z is like the same side, specifically for the Cunningham pre-log system. R and S were but I'll just check the notes and explain to you. But I know for Cunningham, ama rudi kwa hiyo swali nione sasa umeenda chini. Ni sawa tu, endelea tu. I'll find the question.
I thought ni opposite.
Okay, ni wewe Leting.
Soja
Ah,
ndo unatoka nini? Unatoka seminar.
Mina gani hiyo? Nilikuwa nimeenda
Umetuletea
tu.
mali Soja.
nimekuletea mali usijali.
Top.
Ngoja siwezi sema hiyo,
Hapa sawa.
kumbe narudia.
Wewe si nini na tuko on record hapa.
I thought like E, ukiflip either side, like both groups ziko on the same side.
High priority groups ziko same side for E.
Yeah, I thought ni hivyo, and then Z ni opposite. Like
Maybe
regardless.
wacha tu niangalie notes ndio tusidanganyane hapa. It's better ama just Google badala kutafuta hizo na PDF zote.
Sawa.
So can Ingold Prelog rules.
Okay, so your E and Z designation, hiyo ndo unatafuta?
Hiyo ndio tunatafuta ya for that question yenye tumepita.
So for Z means the groups of higher priority on carbons are on the same side. Like zote ziko juu.
Z,
for the-
hiyo ni ya Z.
Yeah, but for the E
Uh-huh.
designation, they are opposite to each other. Like moja
Okay.
iko juu, ingine iko chini, but on opposite side.
Of the double bond.
Yes.
Okay. So for hiyo can Ingold tuko sure ni hiyo Z and I wish I took a wait, table scroll hadi hapo please. Wait, I think it was number, I don't know, 60 something, 50 something. Nafika namba 20 na tujaiona bado. Oh,
Pastor, unaona vizuri kweli.
ninunulie miwani mimi sasa.
And I
Ndio hiyo. Can Ingold use to description about the chiral center uses dash symbols. Configuration about a chiral center.
So it's Z and E because okay, nimepata from Google. Each substituent is assigned a priority using the can and gold premium rules. If the
Diana, una
priority-
fed
using the can in gold prelog rules, if the two higher priority substituents are on the same side of the bond, the configuration of the bond is Z. And if they're on opposite sides, the configuration is E, using the can in gold prelog rule. Like they use those rules to designate your Z and E. So that's why it's Z and E.
And mi ninaona hapa kwa Libra text inasema, so we're talking about configuration about a chiral center. Can Ingold Prelog rules inasema the method for this is formally known as RS nomenclature. For Can Ingold Prelog rules. And may I really
Okay.
believe this side.
Mtume link.
juu hata last time tukinini kuna msupa alisema ni hii R&S.
Because tunaongelea swali inauliza about configuration about the chiral. I'm trying to put full stop. Configuration about the chiral center uses.
But what's a chiral center? See, the four groups, they're not similar.
Yes.
Like what is it different?
Yes.
Na inakwanga like a double bond or whatever. Is it chiral center? Is it
Si lazima
necessarily a
ikuwe double bond. It can have
It's not.
different groups na isikuwe na double bond. Yeah.
Yes. So by the fact that it's a chiral center, it doesn't really change things. It's just that hiyo prelog system ndio inatumika kupeana the Z and E symbols.
Haitpeani R&S. Walai tuko mi naona hata ni R&S now, and that other time I was convinced it's Z&E, but naona kama ni R&S because the question is asking the Kern-Ingold convention used to describe configuration about a chiral center. Acha tupige a bit more research.
Hebu niulize
Configuration about a chiral center, Kern-Ingold. Rules for Kern-Ingold. Yes.
Oh, nimeiona. Yeah, kuna ingine
Umeona
inasema the chiral, yeah.
R&S. Hata kuna video hapa for
Yeah.
determining posterior isomerism, Kern-Ingold pillow convention determining R&S. For configuration because Z&E tumeona ni ya assigning priority across like on a double grid, which is not what I think it is. Sasa time inaacha kushare.
Yeah, so I think ni R&S. Hey.
oh,
Right.
so umesema tuende na R&S.
Okay. Me at least ninaona kama ni R&S. Diana, wewe unaonaje?
Ni
Ama
R&S. I'm
ni
convinced.
R&S? Even me, I'm
Yeah.
convinced. Even okay, whoever okay is, ni kama ni hiyo R&S. Thank you for bringing that to attention. Sasa una kitu ingine ya kutufunza leo?
Let's see. Which one of the following forces causes nonpolar molecules to aggregate?
Non-polar molecule.
Razon.
Sasa unaita nani chai?
Razon. Haiko area.
Huyo ako area, huyo ako kazi anatafuta pesa.
Hata riziki.
Ama ako matatu saizi, usiache usifanye atokwe simu. Anatafutia watoto. Watoto ni wewe, you are the children. Ni hiyo dipole interactions kweli chai? Non-polar molecules.
Si van der Waals.
For non-polar.
Because me, I'm thinking for non-polar, it's van der Waals. Lakini
Dipole is not used for non-polar molecules. Hydrogen bonding.
Hiyo tunaenda na Dr. Manjari.
Twende na hiyo van der Waals forces. Na Manjari hata wewe uingie ChatGPT ndio ama uko sure niache kukushuku hapa. Acha nisikushuku daktari. Acha tuwe tuna van der Waals.
mi niko hapa jikoni nasonga ugali, we ingia ChatGPT utafutie jibu.
Sijui hata mimi nataka kuingia jikoni.
Hajui kupika ugali, wewe enda huko Kitale ufunzwe mambo ya ugali. About ethers and alcohols, no, that's not really.
Ini medic
Si medicam, hii ni
organic.
organic. Ethers have lower boiling points. Mhm. Okay, C for sure is true. I think D is true. It's between A and B. Lakini chai tulikuwa tunatafuta maswali za dissolution na solubility. Ama zimeisha zote?
Yes. Which of the following routes of drug administration is least likely to result in systemic absorption? Hiyo ni
Hiyo ni topical. Least likely to result in systemic absorption. Sublingual, definitely. It has resolved.
Topical ama?
Or
Yeah.
mi naona ni topical too. Hebu rudi juu kidogo. Stop. Your half-life of a drug, hiyo ndio jibu kweli. These are not the answers we've gone. These are the answers that we found on the paper. Hiyo unaweza enda na nini? I don't think it's A. Maybe B. Half-life. Half-life is 75%.
I think I would go with B.
Even me, I'd go with B. Half-life cannot be 75%. Influenced by rate of metabolism. Because in patients, it will increase when patients with liver disease, not decrease. This is when drug absorption slows down. B. Naona ni B. Endelea tu. It's mostly on. Wachai, wewe umechoka kusoma maswali wewe.
Oh.
Una scroll na usome. Ni gani sasa?
I don't know, 122, I don't think that's pharmaceutical. Is it?
Yes. Kama kuna jibu unasema tu tukisonga.
They're
It
right.
doesn't
They
matter.
are protein binding. Which one of the following routes of drug administration is associated with the high bioavailability?
With the highest, hiyo ni definitely intravenous.
Highest. Maybe. The rate of absorption of a drug can be increased by particle size reduction. I think it covered this.
Hata unajua tu bila kusoma. The trough in a plasma concentration curve of a drug is the lowest level of a drug in kama ni pharmaceutics tu ndio maswali ni ngumu ngumu. Huko mbele there is hope. All the following reduce oral bioavailability of a drug except Chai, utanilipa kama unataka nikusaidie kusoma maswali wewe.
Oh, fresh.
Ni gani sasa wewe? Wewe sasa una lead discussion alafu unanyamaza una scroll.
Hapo nalala.
Unatufanya hapa tuanze kusorota.
All the following reduce oral bioavailability of a drug except you have fast pass metabolism, high water solubility, complexation reactions with dietary components, and esterification of polar parts of a drug molecule, and the elimination.
Ina reduce, so hiyo iko
Worst
sawa.
binary. I don't know how water solubility reduces.
I don't think it reduces. What even impact does it have on bioavailability if a drug is more? In fact, would it reduce? Let us
Dissolution.
Si tuna swali nauliza oral bioavailability. High water solubility. Your drug complex, the bioavailability of the drug itakuwa low. So C is okay. A is okay. Esterification of polar parts of a drug molecule. I think I'd still go with B as a matter of elimination. Lakini we mwalimu
I think esterification would make it itafanya ikuwe less soluble. So hata mimi ningeenda na B.
Esterification itaifanya ikuwe less soluble.
Hapana, inafanya more soluble esterification.
And so if both B and D zinaongelea the same thing.
All the following reduce oral bioavailability of a drug except high water solubility. It reduce
water solubility. I don't know, but I think kama it's at least slightly soluble, then it would at least help with absorption, which would in turn increase bioavailability instead of reducing.
Yeah, that's why I think B is the most appropriate answer.
Lakini mimi mambo ya esterification hiyo nayo sijui.
Lakini ukitumia elimination utabaki tu na B. Which I do you agree?
No, I'm not sure. I'm not sure. I don't know what D does.
Tulienda na B though last time tulipitia hii swali.
Wazi Dr. Stonebridge.
Namulisale. Ceiling effect iko sawa. Chaiwe lamba glucose unasoma polepole sana.
A ceiling effect of a drug occurs when there's no clinical response. No clinical response occurs with the increased dosage. Proteins involved in active transport are saturated. Renal excretion is overwhelmed. Tolerance occurs. There's no clinical response. You can't angalia effect here. Drug interactions involve all the following. This is seen in pharmaceutics. inaweza kuwa a lead compound
Is a
is
starting
an
material.
yeah, it's a static material.
Last time walisema si, hebu rudia juu.
Hiyo ya lead compound.
Alisema
Imagine ulisema si, hebu acha nisome hizo maana ni.
Hebu rudi juu kidogo. Roll up a lead there. A lead compound lacks a chiral center.
No, ndo nasoma maswali. Nasoma majibu, but nilisema D, and then later on they changed. They said it's not a starting material for lead compound. I think it's
A.
Yeah. But I'll confirm. Acha nitenda kwa let me confirm in a few minutes.
A new molecule proposed for a particular
molecule
therapeutic is
Yeah,
that also
hapa.
sounds right. Sijui kagaya sako sijamsikia.
A minute.
The following is okay.
Okay.
At hiyo antidote for methanol poisoning ni nini? Sorry,
Ni from epidural.
na ya ethanol poisoning ama ethanol ilikuwa nayo, but ya methanol ni for mepizole. Sorry, carry on. Sorry for interrupting.
Chai, go back. Rudi hapo juu kidogo.
Unazitumia ethanol pia for
Hiyo ya
that
hypochromic anemia. Hiyo namba hiyo 138.
The drug of choice for hypochromic microcytic anemia is
Ninataka mnipe jibu.
sasa folic acid ndio tunaita drug.
Alafu B12 is for okay. Anyway, sawa.
Wacha kusema sawa. Sawa nini? Vitamin B12 ni ya nini?
I've seen what I was looking for.
Vitamin B12 ni megaloblastic ama?
Megaloblastic anemia, but si swali you're correct. But si swali inauliza drug of choice for treatment of hypochromic microcytic anemia.
Yeah, it's because most of the times wana confuse folic acid na hiyo B12.
Okay. Na ferrous sulfate ni ya nini? These different types of anemia are caused by different deficiencies.
Hii ni tunapewa na iron.
Daniel? Microcytic anemia. Chai, hauko clear man. Hebu tuangalie.
So ions ni ferrous.
Ferrous sulfate.
Yes, unaweza peana hadi kwa hemorrhage ama?
Nini ya?
Ferrous sulfate to replenish blood.
Don't know if it's
Ama
like
hiyo
this.
menorrhagia.
Tunaposikia, unajua I'm still googling here nione. Nasema vitamin B6 deficiency is associated with microcytic anemia. Hii tumesema jibu ni folic acid.
Microcytics ndio iron deficiency.
Iron deficiency anemia.
Because unapeana iron.
So in short, unapinga hii jibu. Yeah, naona hapa the answer should be ferrous sulfate. Yeah. Kama
ni ferrous sulfate nimeangalia.
Ni ferrous. Yeah.
Yeah, hata Anita I think kwa chat kuna
ndio hata nimeona hapa sahi. Serafin, unasikia? Ama unapika ugali hapo, tumechange jibu. So the drug of choice for polycystic anemia is ferrous sulfate. Chai endeleza masomo.
Pernicious
Pernicious
anemia
anemia,
is associated with malabsorption of
sio B12, maybe B6. Pernicious.
I think it's 12.
It's 12.
Yeah.
Ni the same as inaitwaje hii ingine?
yeah, I think the vitamin. But
Yeah?
I
Katika
think
hiyo
the
chili.
vitamin B12.
Ni the
Ni
same as
B12.
megaloblastic ama it's a different. Ukiwa na vitamin B12 deficiency ama hiyo si
See the same,
it's not the
though
same.
But it's not the
both are
same.
caused by a deficiency of vitamin B12.
Okay. Is that what pernicious anemia is? Megaloblastic is just a deficiency of vitamin B12. Okay, thank you for that.
Endelea.
Tuendelee.
Yo guys, do you focus on hizo maswali za nani ama hizi zingine?
za pharmaceutics.
Yeah, must.
Must or
Kama hiyo chemotherapy si utueleze.
Hiyo ni hiyo filgrastim ama Neupogen. The other name of filgrastim is atumia Neupogen. Yeah.
thank you, Dr. Stakolaris. Xerophthalmia is due to deficiency of hisi ni ile ya macho. Right, sama. Yeah, so I guess vitamin. The role of calcitonin in the body is to enhance synthesis of urine bases, regulate calcium homeostasis, enhance the synthesis of clotting factor 2 and 7, enhance, strengthen connective tissue.
Near calcium.
I think near calcium. Concurrent administration of probecid and piperacillin may cause paralysis. Yeah, he's right.
Ni hiyo prolonged blood concentration of
Alafu hiyo calcitonin inakuwa produced na C cells in the thyroid gland. Maybe inaweza nani? Inaweza saidia.
Okay. Thank you.
Which is a neuramidase inhibitor. Cyclovar, phosphanate, zanamivir, cidofovir. Sasa nimesahau watu wameipitia. Yeah, it's zanamivir. Which on all the following are non-nucleoside reverse transcriptase inhibitors except and RTIs? Verapin, again, favirenz,
Inasema except, so ni D. Ama mali imefikia tuangalie za pharmaceutics.
Yeah, your time.
Yeah.
Diana, do you have any paper unajua iko na hizo maswali?
Hizi ni calculations za Seraphine. Hizo I think tutafanya
Manjari kuja hapa.
tutafanya hiyo
Unataka
time ya pharmaceutical calculations ndo atatuchanganya.
actually hata tutapiga tu 2 minutes of theory then we do these examples. Hakuna kitu nimeenda kudiscuss kwa hiyo textbook.
Sawa sawa. Songa tu. Hiyo semi solid. Yeah.
Yeah. Emulsion.
Yeah.
The branch of medical science that deals with the dose or quantity of drugs to be administered is termed as solid.
Yeah. Niambieni kwanza tincture ni nini?
Zile ni mshuka tunatengeneza za sodium. I think
Alcoholic. Alcohol.
iodine. Reliability testing of tablets tests hardness, thickness, uniformity of weight, ability to withstand pressure.
Iko sawa.
Which one of the following is not a parental route of drug administration? Intrathecal, subcutaneous, transdermal, peridural. I think peridural is how and I don't know if peridural is a method of drug administration. Peri ama epidural. Sidhani kuna peridural.
Peridural tumesema hata ni nini, ama walikuwa wanamaanisha epidural?
Nimeona wanasema it's part of the parenteral injections.
Hiyo peridural.
Hebu ni epidural ama ni sijui.
Kuna peridural bro.
Peridural ni nini?
Sijasikia, mimi najua epidural.
Epidural. I guess wanna to trick.
So
hizo zingine zipo.
hata transdermal ni parenteral.
Peridural iko.
Iko. What is it?
Like ukigoogle inasema peridural is an injection yenye wanadunga mahali kwa dura mater. So I guess huwa ina exist, I think for anesthesia or something. Yeah.
So bado tunaenda na transdermal.
Ni kama because if
Many
it's
have
an
searched for
injection,
examples of parenteral and transdermal is not one of them.
is not one. When I was
Yeah.
looking at
Is peridural an example?
Pia peridural
Is
hakuna, but sasa
S3,
ukisearch
IM,
meaning ya
IV, na
peridural,
intrathecal.
but it
yeah,
describe peridural as an injection. Ama what have we said it is? It is.
yeah, an
Yeah,
injection into the dura.
yeah. So that sort of falls at that parenteral.
So transdermal.
No, it's transdermal. If we go with what we have said peridural is.
I think it's transdermal. The addition of large concentrations of certain additive increase aqueous solubility standards. In the nini sijui
Ya kwanza we ni lecturer wa solubility unafaa kutupea jibu. The addition of large concentrations of certain additives to increase aqueous solubility standard. To increase solubility. Searching solubilization. Okay, wamesema solubilization is the increase in solubility of a poorly water soluble substance with surface active agents. Increase in solubility. Not complexation.
Inakaa tu solubilization.
Inakaa tu.
Yeah, from
Just
then
wanasema in large concentrations because solvency is not in large concentrations. Inatumia tu hizo ma products fulani. Yeah, ethylene glycol, propylene, kina ethanol. I don't think there's any other compound that I have to use it in large concentration.
Ati nini?
Sema kwa solvency alikuwa anasema tunaongeza hizi agents hizi ma akina ethanol. But there was no mention of hizo nini zikiwa in large quantities. But considering Kenya Dana alikuwa anaongelea juu ya surface tension, si ndo fike hiyo CMC ya speed and safe.
Dana hujasikia swali yako
Direction ya
hapo.
CMC.
Oh, sorry. What was the question? Napiga
I'm
ugali.
saying when you're talking about the surface act, nini
Mhm,
hizo micelles.
mhm.
Si micelles ndo what you get once you reach the CMC.
Yes.
And so for you to get there, see, you have to add to use your nini in excess.
Yes.
So yeah, maybe it's solubilization. But by definition, I don't know what solubilization is. Because hapo wanasema
Acha ni-
Yeah, that's it.
So solubilization from Google.
Mhm.
Increase in solubility of a poorly water soluble substance. Okay, so and the question is the addition of large concentration of certain additives. An additive could also include surfactants. So to increase aqua solubility, it's definitely solubilization. Yeah. Then number 180, which one of the following is false regarding flocculation in suspensions? The answer is definitely causing caking of suspension. Caking occurs with deflocculation in suspensions because with flocculations, they form loose aggregates, floccules, such that when you shake the bottles with suspensions, they resuspend.
Moving on. Surfactants used as emulsifying agents in oil, in water emulsions, have a HLB value of
Okay, so for oil
oil
in
in water
water,
emulsion.
they are the ones which had an HLB value of more than 9.
Yeah.
And the ones that had values less than 9 were water in oil. So anything above 9.
So 8 to 18 is the most appropriate answer there.
Yeah.
Okay, in penicillin injection is an example of I'd say B.
Yeah, I think so.
Dissoluble. Kabisa. Which of the following statement is true about microcapsules? May consist of a liquid core containing one or more drugs enclosed in coating. Size range of 1 to 2000 micrometers. Gelatin is not suitable coating material and can be produced by spray drying. So following is true. Do we spray dry a microcapsule? Guys, give me a minute. Come.
Yeah, so a microcapsule consists, consists of a semi-permeable spherical, thin and strong polymer membrane surrounding a liquid core. So it may consist of a liquid core containing one or more drugs enclosed in a coating.
Okay. Diana, do we just continue or we wait for Chai?
I think we can wait for him hata amerudi.
Yes.
Back again. Next copy.
Tuko hapo 3 basic principles of packaging.
No. The 3 basic principles of packaging are protection, containment, and identification. Labeling, containment, and tamper-proofing. Identification, containment, and labeling. They have to be not tamper-proofing, containment, and identification.
Containment lazima iwe na identification. Inaona hii iko tu sawa.
Same. Yes.
What you said again? Hey.
Yeah.
Yes.
OTC preparations are medications that can be purchased without prescription. Yeah. Medications that can only be purchased from a supermarket. Medications that can only be purchased. I think it's I'm going to go to tumekubaliana hiyo OTC. Ladies.
Yes.
Yes. We agree.
Twende sasa.
Each one of the following advisory labels is recommended when dispensing metronidazole tabs. Protect your skin from sunlight. Faster. Take the medicine on an empty stomach. Do not take with medicines containing iron or zinc. Take with or just after food or with a meal. That is correct.
Yes.
Preferably a fatty meal. Improving whatever absorption. If a drug has a plasma elimination half-life of 4 hours, how much of the drug present in the plasma will be eliminated after 8 hours?
Your half-life, your calculation of
Like,
half-life inakuanga na formula ama hiyo inafaa kwa common sense. 50% is eliminated after 4 hours. He, mi acha nisiongee masaa ya maths please. Diana, we unmute.
I think A is okay.
Easy, iko part of the
Hey.
calculations.
Really, is it?
Yes,
Yeah.
it is. It is.
Mambo ya half-life haiko kwa pharmaceutics, but si half-life
Ko.
ni kureduce whatever iko to half. So during the first 4 hours, it are reduced to 50%. Then in the next 4 hours, it does again half of 50. So it
Of
does
50%.
25%. Yeah. Yeah.
Okay. Asante sana mathematician pale. It makes sense. I think A iko
So
sawa.
answer ni, sorry.
Ni A.
Kuna kwanga na
75.
formula.
Iko. I
Ebu
think we were taught by Larry. Larry taught us the
Kama
formula.
kuna
Yeah,
formula, I can
inakwanga
try
sijui
find it.
3.5 is equals
Yes.
to something like 0.693.
Raised to something. I don't know. Can't
Sawa.
remember.
Something.
But hiyo
Sawa, nitaitafute.
hiyo yako kienyeji Seraphin bado imeeleweka usijali.
Me, I use kienyeji by the way. So kama mna expect ma formulas,
Hiyo
shida
kienyeji
itawapata.
Sawa, Steve Hawking.
Oh, hii haina time.
ulipata formula?
Nimepata formula ni 0.6. So half-life is equals to 0.693 times volume of distribution over clearance.
Hiyo ni complicated.
Hata tuna hizo
Okay, kuna
view.
ingine ya K is equals to 0.693 over half-life, where K is the elimination rate constant as a fraction per unit time. Wacha tuone.
Wow.
0. point-
Manjari, hebu explain hiyo formula yako.
Atatumia
Huyu
formula,
anaga
ametumia logic.
formula.
Mimi sina
Ametumia
formula.
Anaga
logic.
formula.
Hiyo ni akili tu.
Hebu
Hakuna
explain it.
formula hapo.
Hebu explain tena.
Oh no, me I've just
How
said.
you got
See,
to
half-life
75?
half-life is the time taken to punguza the concentration to half, the plasma concentration to half.
Yes.
Yeah.
So the first 4 hours, if the drug ilikuwa 100%, so the first 4 hours inaenda to 50%.
Correct.
Then in the next 4 hours inaenda again half of what is present. So half of 50.
25.
Then unapiga summation pale.
Unapiga hapo summation yako kama umeondokea.
Mi napata 40%.
Hapana,
Aje.
Diana, aje sasa. Tumia hii bonoko hii ya Seraphin. Unajua ukiapply tu.
Nikiapply formula labda
Kama drug iko na half-life ya 4 hours, ukimeza sai, at least we know for sure by 4 hours, 50% of the drug has been metabolized, karibu ikuwe cleared. So I think mi kwangu hiyo ime make sense. Ndio ikuja 75% after 8 hours. We, Chai, umekamata
Yeah.
tuendelee.
All right. Tumesema 25.
75.
Okay. Oh yeah. Yes, I mentioned. Which one of the following vitamins is given to newborn babies to prevent hemorrhagic disease of the newborn? Ni vitamin K. Ndio hizo ma bleeding. Hizo clotting factors. The appearance of crystals in a mannitol injection solution indicates that the product was formulated using sterile saline, has settled during transportation, contains impurities and should be discarded, was exposed to excessive cold. I think it's cold.
Ni cold. Cold temperature ina affect crystallization ama ni specific for immanitol injection?
Yeah, I just assume that even your reduction in temperature rate cause your crystallization.
Okay.
Like it's more likely.
Yeah, hata Google imesema hivyo.
Nimekubali.
A prescription order includes directions that AUGID. Which of the following auxiliary labels should be affixed to the container? For the eye, the ear, for the rectal use, to be taken with meals.
I think that's not okay. Siko sure. It's for the ears. I think it means you put in both ears or something like that.
Hadi unajua Latin correct?
Sini we kwenda huko.
Nasema huyu ni profesa huyu.
Yeah.
Hiyo gut hiyo GUT inamaanisha drop.
Drops.
Yeah, then AU means left and right ears.
Yeah.
Na maybe ikiandikwa BT is the bedtime.
Na Diana, either of the ears, like kama unafaa kuweka kwa only one ear, what are those nini? Hizo abbreviation. AD ni ya right ear.
AD ni right ear, AS left ear, AU both ears.
Okay.
Jesus. Si mumeiva madada zangu. Jesus Christ.
Ni Google.
Hachana. We, sawa. Chai tuendeleze, wewe acha kuzubaa manzi.
Yeah, German. Endemic means that a disease occurs clearly in excess, is habitually present in human population, affects a large number of countries simultaneously, exhibits a seasonal pattern. What's the difference? A large number of countries. Isn't that pandemic? See, is habitually present in human population. I think so. For example, we would say malaria is endemic in East Africa region. Tumekubaliana on hiyo mfano.
Sawa chai.
Huh?
I agree.
Several studies have found that approximately 85% of cases of lung cancers are due to cigarette smoking. This measure is an example of incidence rate, an attributable risk, a relative risk, prevalence risk. So that's prevalence. Incidence is the new rate.
Incidence ni?
New rate.
New rates. Mi sikusikii chai.
Yeah, the new rates of a disease. Like, yeah.
Okay. So prevalence.
As a confirm if that's the case.
So incidence rate ni number of newly diagnosed cases of a disease. So you divide the number of new cases over the number of persons at risk. Okay. Kuko sawa chai.
The back. A relative risk can be used when the frequency of illness is the same as the population prevalence with any pharmaceutics.
Tumekuwa tu tukijibu tu vitu hapa.
Endelea.
Mhm.
Aina ile unit ya ule jamaa alikuwa anatufundisha akiwa Germany.
Mhm.
Ile hapo yako.
Anko ya nani?
Yako yako.
Anko ya Jari.
Relative risk can be used when the frequency of illness is the same as the population prevalence. A large sample of consecutive hospital patients is enrolled. The study has designed with cases and matched. People who are exposed to the factor of interest are likely to have the illness. Hapo. Hizi ni research.
Hizi zinakaa research.
Let's see kama tapata zingine za pharmaceutics. Diana, si tuangalie if you have any paper.
Sorry?
See if you could find a paper iko na nani, iko na hizi ma we're going through this.
Allow me niangalie for tomorrow mchana, then tutapitia kesho.
All right.
Is that okay? Sawa.
Let me see if this other document iko na ini.
But kesho utafanya hiyo from partition coefficient.
I found some questions here, but they're not
Right.
very visible. Huh?
Kesho so utafanya hiyo from partition coefficient, right?
Yes, tupatie soja atupeleke na hizo manani. What time?
Right. Okay, huwezi asubuhi?
Anyway, naweza nini? Sidhani iko na vitu mob. Nimepata maswali kadhaa za pharmaceutics. Let me share the document. Manjari amesema atatupeleka through hiyo partition coefficient.
Nani huyo? Kwani kuna Manjari mwingine siku hizi
Sawa,
na sijamjua?
thank you Manjari.
Thank you so
Asante
much.
sana. Thanks Prof.
Asante. Yes, thank you.
Wacheni niwaambie.
Asante Prof.
No, I'm not doing that. Poleni. But pia siku yenye mimi nina discuss whatever I'm discussing, I want to do it in the morning. Jioni kidogo.
Okay, Seraphine, what if your calculations we do it tomorrow? Because Chai amesema he's not available mchana.
That's okay.
Yeah, we can do your part kesho mchana.
Mchana.
Yes.
Na saa ngapi?
Thank you. Seraphine, saa ngapi?
Anytime mnataka.
Wewe amua tafadhali.
I am available
Ama
from
10
9.
tu. From 9.
10 sawa. 10.
10. Okay, 10.
Guys, mkiona nini mnisho.
And then so Chai jioni utamalizia hiyo partition coefficient, right? Utumalizie hiyo ya solubility.
Partition
Hiyo
coefficient.
part ya unaona
Okay.
like according to the guideline maybe hizo zenye hujakava.
Yeah.
It's
But you guys
you
hamko
can also,
mmeiweka. I didn't think they test it until nimeiona kwa maswali.
Yeah. But iko
It
kwa
wasn't
guidelines.
in the
Yeah, iko kwa guidelines, then
ndo hizi maswali.
usipopata kwa notes, we can use YouTube if you don't get the notes.
Hakuna notes by the way.
Especially your states of matter, blah blah blah. We can use YouTube. Sonia, tumechoka.
Yes,
Umecheck?
yes. You can see my screen, guys.
Yes.
Kabla nani aanze kung'orota. College is it? Yeah. I think college is but pharmaceutical. A college is best described as one phase system, a system with at least two discrete phases, a system which consists of a powder phase, a system which consists of air as a dispersed phase. College.
A system with at least discrete
Two.
phases. Mimi naona hivyo. Prof. Diana, lazima confirm before tuende next. A colloid.
Yeah, colloid iko na phases kadhaa. Iko the dispersed phase, the suspended particles, and a continuous phase.
Yeah. So those are the two discrete phases. I think that's okay.
Peaking in a suspension implies formation of brief phases, aggregation of particles to form a hard mass that is not easily dispersed. Okay, a color change, formation of easily dispersible phase. Aggregation. Aggregation.
Hiyo kicking tulisema ni ya flocculation ama ni ya deflocculation?
Deflocculated.
Deflocculation, okay.
Mm.
Thank you.
Deflocculation. Okay. Which of the following?
Deflocculation ndio ina form hiyo cake yenye ukishake it can't disperse easily.
Yeah.
Deflocculation.
Ndio ina form ni deflocculation.
Deflocculation iko sawa.
Oh. Okay.
Which of the following is the most commonly used as a binder in tableting? Acacia, sodium alginate, camelose, sodium, lactose. I think ni that Spiderman alikuwa nayo aliongelea nini pharmacognosy.
Hiyo acacia.
Acacia gum. What is the role that we can still nini? Sana unaweza confirm?
Sorry gani hiyo?
Which of the following is the most commonly used as a binder in tableting? Yeah, let's go on. What is the role of disintegrants in tableting? To improve the flow properties of the tablet mix, to ensure that the tablet breaks down upon ingestion, to prevent the deterioration of active ingredients, to enhance taste. I think to ensure that it breaks down.
Yeah.
Okay.
Alafu hiyo most commonly used as a binder. It's not lactose?
Lactose is actually a common binder.
Please confirm. Tuendelee. Hard gelatin capsules are solid preparations
Scroll chini
intended
kidogo cha. Kama ni mimi tu sioni kwa skrini yangu hivyo. Yeah.
Hard gelatin capsules are solid preparations intended for rectal administration, can be used for non-liquid drugs, have a shell made of starch, are intended for containing antibiotics only. Yeah.
Yeah, I'm thinking B. Because soft gelatin sana sana zinakuwa ya liquid drugs.
Mm. Hard gelatin capsules ni kama hizi tu capsules za kawaida like let me see let me just look image hard gelatin.
Capsules za kawaida is hard gelatin. Soft one ni
Ndio.
kama like omega-3 capsules.
Oh, ama hizo Gofen, those soft ones like
Those ones, Gofen, yes.
but I think it's B.
Yeah, because soft and those are whatever the liquid. As Diana amesema. The role of suspending agents in the suspension is to remove trapped air in the suspension, slow down sedimentation rate, enhance flocculation of particles, act as a preservative. Yeah,
Ni hiyo slow down.
because I think most of suspensions are they're prone to whatever, the sedimentation. Hesabu za manjari.
Natupeleka hizo calculations lini? Ni kesho?
Kesho mchana.
Madam sema masaa ndio
Yeah.
tukue available.
Alisema yako available from 9 but 10.
Alisema
I
10.
think acha tu ibaki 10.
Sawa.
Ndio Stano atakuwa ameamka.
Sana.
Diana, hiyo ni form gani?
Kadhaa. Kila mtu anajua form zako. Which of the ingredients is a glidant? We have microcrystalline cellulose, sucrose, dextrin, coprecipitate, magnesium oxide, acacia. A
Oxide.
glidant. What's a glidant?
Na hizo kwa hiyo components in tablet. Acha tu nikuangalie. Glidant to enhance flowability of powder. An additive. The reducing interparticle.
And what was the difference between a glidant and a lubricant? Because there kulikuwa na difference. Glidant ilikuwa flowability, then lubricant was for
Friction. Friction, alafu nyingine solubility.
okay.
Friction ni lubricant.
Yeah. Hizo vitu Sojali enda wana showcase huko. The oral solutions and suspensions intended to be administered as a single dose, such as 50 mils, are referred to as. Okay.
Ni hiyo drought. So hapa nikaa unaenda tunajibu
Sasa hapa
yenyu.
mnapima pharmacology ama mnapima kizungu shwali?
Hiyo ni number 70.
Eh,
Ni drought.
Laptop
It's
yangu
a
ni ghorofa aje.
quantity.
leo ukipiga elimination utaandika hiyo, but honestly
Sasa najua nafungua, but please scroll down a little. Mimi sioni options zake.
Ama
Thank you.
ongeze
Kutafutia binoculars.
Like haiko kwa screen. Sasa umeenda chini sana. Hapo. Rules solutions are intended to be administered as a single dose. Umesema ni hiyo D. Okay.
What quantity of sucrose is contained in syrup simplex?
ni hiyo 66.
6.6%.
Which diluent is most appropriate for chewable tablets? Calcium hydrogen phosphate, lactose, mannitol, sodium chloride.
Mannitol.
Unless otherwise specified, a hard gelatin capsule is expected to disintegrate within 60 minutes, 30 minutes, 40. That is for hard gelatin.
I feel like tunafaa kutafuta notes za hiyo.
Yeah.
Ile disintegration. I think
You see a capsule,
hiyo pia ni important.
and also should we cover easy stories, suspending agents, stories, buffer agents, stories, preservatives.
Hizo madai excipient. Yeah, ni 30 minutes. Disintegration time is 30 minutes. Soft capsule is within an hour. Enteric coated is 2 hours.
Which of the following factors has a minimal effect on bioavailability of the administered drug? Minimal effect. Please. Yes, I know.
okay, me personally I have no idea by the way, because akili yangu inaniambia zote zina affect.
Extent of protein binding. Minimal effect. Labda tujaribu elimination.
Na venye zote zina make sense.
Organ. You would say gastric emptying.
Even me, I think it's the of all the four.
Everything held constant.
Hiyo nakubaliana na wewe Kihonyi. Hiyo iko sawa. Okay. Extent of protein binding, it affects a lot, not minimally. Formulation of the drug, of course. Yeah. I think kwa hizo it's the best option of the four.
Anyone of different opinion?
But then if it's an oral like drug, then the rate of gastric emptying is actually a big factor.
For bioavailability.
Yes, ninaona
But-
hapa it's one of the factors. Gastric emptying, NGIT motility, GI diseases, food and other
That is
substances.
going to always be a factor because it's like constant, depending on how much itakaa kwa tumbo, kwa small intestine.
Swali iko na oral bioavailability ama?
No, they're just saying on
Haina.
bioavailability.
Na hata swali may acknowledge all of them are effects, but which one is minimal?
Na hiyo hepatic impairment.
Ita cause because what if your drug inapitia nini has to be metabolized by hizo enzyme.
Oh, it's a prodrug.
Liposomal enzyme.
Iko activated.
Sasa mnasema majibu alafu mna disagree na zote, then we go back to where we started.
But inasema minimal. Okay, zote zinaweza kuwa na effects, but ni gani iko na
V amesema
dogo?
hepatic impairment.
Okay, maybe tuanze from extent of protein binding.
Hiyo iko na direct effect.
Msipige nini ChatGPT.
Hiyo iko na direct effect. Extent of protein binding hiyo hata hatuwezi guza kama jibu.
Okay.
Formulation of the drug kama ni extended release, slow release, etc. Hiyo si ita affect bioavailability.
Very much.
Okay, hapa kwa pharmacological factors naona wanasema your gastric emptying, if you have GI diseases, if you've taken it with certain foods, fast metabolism, drug interactions. But now if the liver is impaired, first there won't be any. Kwanza tuanzie with the CYP 450, your enzyme system. Maybe if you've taken it with another drug, it's not there. There's no fast metabolism. So it might have an effect, but not really. Ama nyi mnaonaje?
Hii swali by the way ni guesswork tu.
Hiyo ni
Cause
guesswork na mimi
haitakuja.
then to my head hepatic impairment kama nimesonga.
Hiyo protein binding, it's not more of the distribution of the drug. Ama?
Okay. Acha niulize, does the extent.
See, when a drug is highly protein bound, it's not available for, what is it called?
Yes, it's not. Yeah.
Bioavailability iko chini kabisa, the more protein.
Me ningeenda na hiyo extent of protein binding.
Yeah, that would be my last choice. It would be my last choice for zote. Between C and D for me.
Hata hapa inasema bioavailability is inversely proportional to protein binding.
Inversely proportional. So the more the protein bound, the less the bioavailable the drug is.
Yes.
Yeah, protein binding influences the bioavailability and distribution of active compounds.
Me ningeenda na protein binding because it's more of distribution of the drug. The drug inaweza kuwa distributed.
Oh, sorry.
But
Yeah,
if it's
more
more protein bound, it's going to be less bioavailable.
Wanasema hapa higher protein binding drugs that have higher protein binding are expected to have higher bioavailability.
That cannot be correct. That cannot be correct. Higher protein binding, higher bioavailability. How now?
It's the other way.
Yeah. Okay, kwanza tuanze na what is the meaning of bioavailability? It's the rate and extent at which you have the active drug in systemic circulation. So if it's protein bound,
haiko kwa system.
It's not available for use.
Yeah, that's what wanasema protein binding, it's more of distribution rather than bioavailability. Yeah, so me ningeenda
What you're explaining is bioavailability, because you're saying when the drug is highly protein bound, it's not available for use. Kwani what have you said bioavailability is?
No, like mimi nasema when the drug is, when you're talking about protein binding, it's more of the distribution of the drug, and distribution is not equivalent to bioavailability. Bioavailability ni when the drug sasa ndo iko available kutumika, but protein binding ni venye inakuwa distributed to the various parts of the body. Hivyo ndo nadhani, but I may be wrong.
Hiyo wacha tuweke star.
Tuweke star, alafu Jambi akitupiga hiyo topic ya biopharmaceutics atatupea jibu.
Hebu tupige hii swali picha. Wait, let me take it.
Ladies.
Lakini hapa hata inasema protein binding influences bioavailability and distribution of active compounds, and it is a limiting factor in the passage of drugs across biological membranes and barriers. Ama inaweza kuwa imenidanganya.
Scroll left, left. Ni left ama ni right? Scroll screen. Ama I'm the one who is the problem. Let me check. Oh, sorry, it's me. Sorry, it's not you.
Tutakuletea binoculars faster.
Yani mrembo, how IT illiterate are you?
Mimi niko mbaya. Mimi niko ile mbaya kabisa.
Sasa hiyo amezoom yake yote.
Hiyo ni kama hatujapata jibu. Acha tu tutaweka star.
So mnaona hepatic impairment. Anyway, sawa.
Mimi naona either hepatic impairment ama hiyo rate of gastric.
Hiyo rate nayo hapana.
Tumekataa.
Hiyo nayo ina affect.
Unajua swali imesema zote zina affect.
Which has
minimal effect.
No, but rate of gastric emptying, let's say ukikuwa na, there's some drugs anasemanga if you're having diarrhea, yani haitakaa kwa mwili as it should to enhance hizo effects zake or whatever. But so sahi tuko kwa extent.
I think saizi chenye inatupiga hapa rounds ni which one is the most minimal effect of all these
Yes.
four options. 'Cause
Wow.
Tunaweka star twende next.
Okay. The following factors enhance the rate of drug absorption from the small intestines, except we have the folds of the intestinal mucosa, villi, microvilli, smoothing intestine folds. I think the ear folds in hands. Don't know how smooth in any.
I'm feeling there's an ancestor of sugars. Chai umeenda na smooth intestinal wall.
Endelea. In all the following cases, drugs should be in aqueous solution for absorption to take place, except in carrier-mediated transport, ion pair absorption, pinocytosis, convective absorption. Hii pinocytosis ni kama ile endocytosis.
Ati nini?
Hii si pinocytosis. Ni kama endocytosis yenye inakuwa
Yeah, but only about water. It only ni maji tu ndo inaingia kwa ndani ya cell with pinocytosis, I think. So I actually don't even think a drug can be absorbed through pinocytosis because it's only for water. Ama sijui kama ni
it's
mimi
a drug in
sikumbuki.
liquid form.
Yeah?
Let me check.
Doc, kwanza ni pinocytosis whereby the cell pinches off the fluid in hiyo liquid iko hapo. So if the drug is in solution form and iko hapo itapinchiwa iingie ndani ya cell.
So unasema it's not a nini Spiderman?
Mi nasema pinocytosis can't be the answer.
Na carrier mediated.
I was thinking carrier mediated, by the way.
Yeah, because
But I don't know about this ion pair absorption. Sijaisikia.
as long as kuna ions, I just assume there's water.
Ni aqueous.
Eh, but acha niangalie.
Conven, Chait, hebu toa kasa yako hapo. Oh, convective absorption.
Convective hiyo has water, has aqueous.
Convective need. Ai, acha ni. Hmm. Okay.
Spiderman.
Mi naona kama ni hiyo ion pair. Ama all the following cases drugs should be in aqueous solution for. Okay, what I've seen for ion pair. Wanasema an example of ion pair transport. No, that's not what. Oh yeah. Examples. Okay, examples kama benzethonium chloride and other sulfonic acids. They ionize under all pH conditions. That's what ion pair transport is. So basically, the agents penetrate the membrane by forming reversible neutral composite endogenous ions of the GIT, like mucin. Mi sioni aqueous mahali hapo, unless somebody has seen a different. Aya, nani amebadilisha jina yangu sasa?
Nani mwingine? Ni fala.
Naweza badilisha jina yangu.
Mzai, tupatie majibu, acha fala.
Tuambia kama ni hiyo ion pair ama cariamide, because I'm still trying to understand this ion pair absorption. Ion pair absorption of ionized drugs.
Unajibu kwa chat.
Ion pair.
Ion pair. Even me, I think ni hiyo ion pair, because ninasoma hapa kwa another NIH document. Gastrointestinal absorption of these highly ionized drugs. So the lipophilicity of highly ionized drugs at the physiological pH is low. So GI absorption of such compounds cannot be explained by the kawaida pH partition hypothesis. So ion pair between the drug and an endogenous counter ion resulting in an electrically neutral and potentially more lipophilic species is a proposed mechanism to explain the absorption of ionic drugs. Hakuna hakuyasaidia moja. Unless somebody has a contrary opinion in China, naona tunaweza endelea. Hesabu.
All items containing antimicrobial agents should be acidic, hypertonic, sterile, or hydrox. Be sterile.
Sorry, hiyo transport mmesema except.
And pair.
Oh, okay, so
Which of the following substances is not a suspending agent? Acacia, that cellulose derivatives, lactose. Jana ulikuwa unasema lactose ni nini?
binders.
Oh. Acacia and tragacan ziko. How about cellulose derivatives?
Suspending agent. The cellulose. Hiyo iko. Which of the following substances is not a suspending agent? Na kwa
Lactose ilikuwa
example,
binder ama ilikuwa wapi? I think kuna jibu tulipeana huko juu.
I think we were trying to see between lactose and acacia which is the more. Ilikuwa nini? Ilikuwa hiyo ya
It's lactose.
flowability.
Lactose is filler, diluent. Yeah.
So the answer is lactose, okay.
All the following are types of emulsions except oil in water, water in oil, oil in water in oil, oil in oil. Speed.
E.
All the following are trade names of pharmaceutical products except Panadol, Dawano, Moxicillin, Apiflox. Moxicillin is not trade name. IV injections do not disperse quickly from the site, are given for quick response, are mainly used for diagnostic purposes, are mainly used for investigations of immunity and allergy.
You're quick.
Yeah, being a makes sense.
Response. Moving on. The initial growth phase of bacteria in a culture medium is the lag. Hii lag phase ndio wanakwanga wana compete for nini? Ama?
Lag ndo tusemeje, they're mobilizing nutrients, nini. Then log is now when they're utilizing the nutrients, they're growing, they're multiplying. And then start nutrients, the rate in you wanna grow is equals to rate of death. Like if you wanna deplete nutrients, then death is now the rate of death is very high. Juu hawana nutrients anymore. So log is exponential growth. That's when they're growing very fast.
Lag adapting, log growth, stationary, growth, death, toxins build up, nutrients are depleted. as all the following statements are true concerning pyrogens except unstable and unvolatile. I repeat, unvolatile. Their water insoluble.
Your water insoluble.
The most common source of pyrogen injections is the medicament, solvent, apparatus, method of storage prior to sterilization. What do they mean by injections? Wanamaanisha injectable.
Pardon?
Do they mean injectables by injection?
In injections, I think so, yeah. Yeah, it's the apparatus.
All the following substances or preparations must be pyrogen free except water for injection, yeah. Blood products,
Yeah.
intraperitoneal dialysis solution, eye drops. Mask. So this is the exception in silazima when causes of pyrogens. Like it's okay for it to have pyrogens. You guys can see that eye drops there's a specification for sterility, but none for it to be pyrogen free.
Yeah, I think I agree.
The paste-like preparations used externally to reduce inflammation is called yes.
Poultices.
Sepultis.
What was that? Poultices.
Yenyewe wase mko na nini? Energy hamna,
Ante?
kuna nguvu.
Ama tuendelee from number 90 kesho.
Watu wamekula ugali wanasikia kulala sasa.
Speak for yourself, speak for yourself.
Watu wa Kitale.
Watu wa Kitale wamefanya nini?
Wamekula ugali ingine huko kubwa. So wanasikia kudozi. Soft moist mask. Hiyo swali ya poultices, me I think ni hiyo poultices. A paste-like preparation is externally released inflammation. Poultices is a soft moist
Mimi
mask.
hata hapo I can't see kwa sababu I only know what A means. Hizo zingine sijui.
Mi niko Google tu. It's applied to the body to relieve soreness and inflammation and kept in place with a cloth.
This ni kama nini? Kama Rob.
It's also software.
Rob I think Rob is hizo za A.
Poultice ni it's ni kitu ya herbalist. It's made of herbs. Ni dawa ya waganga. Waganga ni medicine a paste-like preparation. Ni hiyo. It's a paste-like, but it's made of herbs. Ukigoogle utaona hata picha. And other and plants and other substances which treat inflammation, especially they reduce
Which treat inflammation. That's the key point. Sawa.
That's the key point. It's for inflammation.
Yes.
Which
So
Go on.
naendelea.
Which of the following emulsifying agents is semi-synthetic?
It's semi-synthetic. Emulsifying agent.
How do you get sodium alginate? The source.
Wamesema
Anasema it's a gum.
na
Sorry.
so hiyo ni ina sound more natural. Wamesema emulsifying agents that are semi-synthetic, examples methyl cellulose and sodium carboxymethyl cellulose. So semi-synthetic emulsifying agents. Kuna new natural emulsifying agents ni gelatin, wool fat, egg yolk. Kuna the egg yolk from animal sources. I think sodium alginate is from a plant source.
So, but wanasema hiyo alcohol is produced from lanolin, and then it's reacted with acetic acid.
It's reacted with
Acetic acid. Doesn't make it semi-synthetic. Wacha tuende na
hiyo methyl imeandikwa directly, hiyo methyl cellulose, but hiyo wool alcohol ni sijui.
But
A solution expressed as 12.5% weight by weight comprises of in 100 hiyo C.
Bini weight by volume.
C.
No, there's a B.
B ni weight grams in 100 ml. Yeah, that's weight by volume.
Yes. Past your bedtime.
Ni past bedtime ya watu kama wewe. How are you still awake masaa?
Wazee kama chai
I'm
siku ya
speaking for everyone. I'm speaking for everyone.
chai siku ya dina ilikuwa hata iko imefika 10 alikuwa ashaanza kusikia kwa.
Naitwa
Siku hivyo.
There are some people you cannot take anywhere. And chai.
Sawa, acha tuache senior citizens waende wakalale.
senior citizens. Asante sana senior citizen.
Na mtume zawadi ya senior citizen.
Na kutumia care package ya nataka ya
Sapi.
nini?
Ikuwe na
Healthcare
ikuwe na
brands.
ikuwe na dawa ya joints, ikuwe na rob na hizo vitu.
Osteocare pale.
Ya hiyo. Ndio
Na
hiyo
hii
sasa.
ligno ama ni lidocaine spray.
Lignocaine spray.
Hapana, senior citizens don't need that.
Ama iya kuna ingine yangu anatumia ya mabega na ya hips.
So ninyi mnajua kazi ya lidocaine spray ni ya nini? Ama mnaisema tu?
Sijui yenye Patrick ametuma.
Kawe gasi cha kunimute. Unajua kazi
Ndio maana tunajua kazi yake, ndio maana tunasema wengine hawahitaji. Senior citizens don't need things like those.
Walisha retire hizo makazi
Walisha
kitambo.
retire.
Ama already iko delayed. Guy, unajua tuko recorded hebu.
Wacheni kurecord sasa, wacheni hiyo story ishi hapo.